spinal cord is shown on this model. We see it start here at the foramen magnum and terminate here on this model between L1 and L2. You can see on this model, they show the approximate location of the vertebrae. You can see them here as cuts through the pedicle of the vertebrae, down in there in the sacrum. And here we just see where the ribs are. We know there are vertebrae nearby. Up in here again, we can see the pedicles of the vertebrae. Why am I telling you about the bones? Because if you want to get really picky, you can identify the cord parts by what vertebrae are nearby, and so you have to start doing some counting, okay? We have learned that there are 8 cervical spinal nerves, so we need to do a little bit of counting, and then we can find where we transition from from cervical to spine to thoracic and so on. Let's get back to the cord. The cord in this area right here is known as the cervical spinal cord. In here, it's known as the thoracic spinal cord. And then here, we actually lump in lumbar, sacral, and coccygeal into this little piece. Believe it or not, read your book, you'll see it's true. Okay?
So
lumbosacral is oftentimes how it's described because it's all jammed together. This model does not show what is called the lumbar and cervical enlargements. There is a thickening of the cord in this area here and a thickening of the cord in this area here. That is, the diameter of the cord broadens here and here. And these are called the cervical and lumbar enlargements. Let me tell you a little bit about that for just a moment. If you take a look at where the spinal nerves are going to and from in this area, they go to these things. And it takes an awful lot of effort to operate these things, a lot of neuronal transmission. In addition, we have a lot of reflexes, which unfortunately I'm disappointed I wasn't able to tell you that much about. A lot of reflexes associated with the hands. So we need a fair amount of gray matter in here to integrate the sensory information that's coming from the hands and generate appropriate reflexive outputs. So we pack up the gray matter in here, and the cord broadens in size. It's the same thing down here. There's tons of reflexes associated with operating these legs. There is a lot of neuronal input that goes into operating the legs, so the lumbar portion of the cord is a bit larger than in other portions of the cord. The cord actually gets very narrow in here. There's not much going on. Doesn't do a whole heck of a lot. Okay. All right. The cord terminates at the conus medullaris, and then it becomes a series of nerve roots. In the past, I've asked students the name of these nerve roots. Most people say the cauda equina, okay? A lot of people call these the lumbar nerve roots. It's not 100% correct. It's only partially correct. So go with cauda equina, the grouping of nerve roots down there, okay? All right. Some other things that we see associated with the cord then are all the spinal nerves. And as you remember your vertebrae, you know that there's a little opening between the vertebrae and nerves can penetrate those areas. If you have a family member like I do who is experiencing narrowing of the openings between the vertebrae, then their spinal nerves are being impinged. That hole is starting to squeeze on those spinal nerves, and they're beginning to experience all kinds of problems associated with that. Pain, numbness, okay? All right? So we have the different spinal nerves, and if we take a look, we're gonna call these cervical spinal nerves up in here, okay? And then thoracic spinal nerves in here. And then it's hard to know exactly where the lumbar end and these sacrals begin, so they oftentimes lump them into lumbosacral spinal nerves, okay? How can we keep track of these things? Well, we see our first pair of spinal nerves come out right here of the foramen magnum. These are definitely cervical. We count 7 then after that. There's number 1, and then we count a total of 8, or we find number 1 and then count 7 more. 1, 2, 3, 4, 5, 6, 7. That's our last cervical spinal nerve. That would make this one our first thoracic spinal nerve, and we would have to count 12. We'd count to 12, and then that would in this, or that would be where our first lumbar spinal nerve would be located. The problem with the counting is right in here, the model maker made an error, and there's a missing nerve, so it causes a problem. So either start at the bottom and work up, or start at the top and work down, but when you get into here, there'll be some problems. Okay, let's get into this area here. This is a transverse section of the cord. We need to make sure we know our orientation. This is the front of the cord, or anterior, or ventral, and this is the back of the cord, or posterior, or dorsal. Okay, how do I know? The cord has a deep fissure on its anterior surface. The model maker has done a reasonable job in showing that deep fissure. The cord has a shallow sulcus on its posterior surface. If you're seeing that deep fissure, that's anterior. That makes this anterior portion. The other thing is, you take a look at these roots. This root here seems to have the big lump associated with it. The lump is the dorsal root ganglion. We know that these are sensory neurons, okay, and their nerve cell bodies are here. That makes this the dorsal root, which makes this posterior, makes that anterior. Why do we bother with all that? Because then all the other parts take the name of where they're located. This is anterior column, or anterior funiculus of white matter cord. Lateral column, posterior column, or funiculus. These are the horns of gray matter. Anterior horn, lateral horn, posterior horn. Okay? So get your anterior and posterior down, and then you can start naming other things. The cord does have a central opening. Books that I've read tell me that it tapers and then eventually closes. But up high in the cord, you have a central canal, and cerebral spinal fluid goes down that canal. As the cord gets down into this area, then central canal disappears. You see the central canal on the model. We also see areas where the gray matter appears to have crossing over points, and not so readily apparent there are areas in the white matter where axons can cross over. Axons do not always have to be myelinated, and if they're unmyelinated, they can cross over in the gray matter, and we call that the gray commissure. The gray commissure. Okay? Where axons cross over in the white matter, it's called a white commissure. A commissure is a place where axons cross over. Okay? So this is a place where neurons that are being stimulated by sensory neurons, inner neurons here, can cross over and share their information with the other side. I know you're asking for an example, so let me tell you an example real quick. I can step on a pop top, just like in Jimmy Buffett's song, step on a pop top, okay? In other words, I think it's one of those tabs that you pulled off the old style beer cans, okay? And it occurs on the right side. So I lift my foot because it hurts, okay? And that is all a reflex action integrated here. But in order for me to lift my foot and not fall down, I have to shift my weight to the other side, which means I'm going to have to contract muscles over there. While I'm going to contract my, let's say, withdrawal muscles here, I have to extend my muscles here so I don't fall down. How does the cord communicate this quickly? It communicates it by sharing the impulse across the gray commissure and stimulating motor neurons in the gray matter here to activate extensors on this side. We flex on this side to pull our foot off the sharp object, and we extend on this side to prevent ourselves from falling down. And that's how a commissural fiber might work. Did I miss anything on here? You'll find out later?